Hi, I'm Mimi Hills. I'm the Director of Product Globalization here at VMware, and I was a member of the program committee for this technical track. We're so glad you could all join us today, and I have the pleasure of introducing Reshmi Krishna. So Reshmi is a cloud application and platform architect with Pivotal, where she works with Cloud Foundry and helps customers transform the way they build software. Previously, she was a software engineer with investment banks and startups on Wall Street. Reshmi has also presented in various conferences and meetups like O'Reilly's Velocity in New York, Spring One Platform in Las Vegas, Spring Users Group in New York, Cloud Native Meetup in New York. She also supports various conferences and causes for diversity, including Women in Tech and the Society of Women Engineers, and she participates in the Grace Hopper Conference for Women, and now she can add WT squared to her resume. So please join me in welcoming Reshmi Krishna.
Thank you, everyone. So can you guys hear me in the back okay? Yeah? So for today's session, we'll be talking about building cloud-native applications. So I have never done this talk before just because the technologies I'm going to talk about sometimes like that only takes an hour, each technology. But for today's session, the way I formatted it is I'm going to give an overview of all the technologies, and I'm going to be talking about mostly my experience. So I work a lot with financial institutions and help them, move their applications to the cloud. So I'll be mostly talking about that. And of course, I've read books and blogs, but I've also seen things in practice. So, there'll also be a lot of stories going through the presentation. And my presentation is divided into 3 sections. We'll be stopping in the middle for questions. So, I want this to be a collaborative session and not just me talking for an hour. That's a long time. So who am I? I think Mimi did a great job. Just a little bit quick plug. I do host and organize the Cloud Native New York meetup as well. There are also Cloud Native meetups in San Francisco, in Mountain View. And what I have seen in my experience for the past 2 years is we got only one woman speaker in New York. So I would really like you guys, if you're there or here, if you want to speak, don't wait, for the perfect opportunity. Do start and, just get yourself going. I think Mimi did a great job. I'm not going to go into it. Just quickly, I've been a software engineer for 7 years now, and I moved from India 12 years ago. My parents live here. I moved to the East Coast, went to UPenn, did my degree in computer science. As a result, I ended up in New York, and once I started to live there, fell in love with it. I worked on Wall Street. Didn't like Wall Street after working there for 5.5 years, and I was working in low latency trading. So then I moved to a product company, which is Pivotal. I work specifically in the Cloud Foundry product of Pivotal. If you guys don't know, this Pivotal is a spin-off from VMware. So VMware is our parent company, right? So I've been working there for the past 2 years now, and I love it. Okay, enough about me. So for today's session, the way I've structured is, and I would love feedback on this as well, I'm going to talk about why cloud native, and why are you seeing these articles and these posts and people moving to the cloud, and why do we even need that, and why should we even talk about it? And being technology, everything has a lifespan of maybe 2 to 3 years. How do you know it's there to stay? And let's say if you want to move your applications to the cloud, how do you even know that it's going to work, right? So we'll talk about why, we'll talk about the what's, and of course the how's. So I've kind of distributed in this fashion, and we will go into it a little bit more into details, into microservices, into 15-factor apps, and the properties of cloud-native applications, and how you should look at an application and think if it's suitable for the cloud or not. Do you really even bother moving it to the cloud, right? So we will talk a lot about that as well. So let's talk about the why first. So how many people here, you guys are building cloud-native applications? You've heard about it? Yeah? Couple? Majority. Okay. So how many people here are building them, are involved in building them? 1, 2. Okay. Half of you guys. All right, cool. So I guess for you all, why might not be so important. Probably you already know the importance. For the rest of you, it's more like, we look at, so I work a lot with financial industries. And when I started working with them, it was all about, I don't want to move to AWS, or I don't want to move to, anything in the cloud just because compliance of security and all of those things, right? I have to fill out this whole audit requirement. The cloud doesn't meet it. But in the past couple of years, what I'm seeing is AWS is becoming as much, if not more secure than your private data centers. And they have added a lot of capabilities in there. Then close behind is Azure, Microsoft Azure. Also, I've been seeing Google Cloud Platform, the adoption starting to pick up. So these three main competitive, infrastructure that's out there. So a lot of institutions, what they're doing is they are slowly migrating not all the applications, but they're maintaining a private model, a hybrid model, where some of their applications are in the private data center, especially their production version of the applications, and they would move their development and UAT applications to the cloud just to see how it is, right? A lot of the competitive advantages, you can scale it, the moment you want. You don't have to wait for your infrastructure. You can have like failbacks and all of those things. You can also have different availability zones. And companies like Amazon, Google, Microsoft, they take downtime very seriously, right? So it's built into their SLAs. So when you put their applications in the cloud, it's built into their SLAs, right? So all of those things are contributing majorly, heavily into people migrating into cloud. Another thing is, user experience is really changing. I remember when I started playing with computers, I would be okay with a page loading for even 3-4 minutes. Now, if it's a second, I get really impatient, right? And even I look at my father, he's the same way now. And he's been using technology for maybe 15, 20 years. He also gets impatient, and the user base is also changing, right? It's not only the age group and the demographics and everything is changing. Internet is reaching even through remote villages, right? So you have a lot of restrictions around that, bandwidth, a lot of those things. So when you're building an application, especially, the instance of Facebook, you will have something like a version for the low bandwidth users, or something that you can, post on mobile versus the user experience that you see on a laptop or an iPad. Those things are different nowadays, right? Also, another thing is in terms of, Thanksgiving. So how many people here have gone into some websites and they have crashed on Thanksgiving? Yeah, even last year it happened to me. So a lot of those things, right? Reacting to events, reacting to certain traffic on Thanksgiving, on Black Friday, all of these events, even when you expect, certain amount of users, sometimes it might exceed. You have to do load testing. You need to react to events. And you need to react to failures as well. So for example, on Netflix, when we log in, the page that you see there is approximately over 250 microservices, and it's written in their blog. And the way they handle that is, let's say if the recommendation service is not working, they have a backup for that. They know if it's not working, you're not going to see a 404 on the page. What you're going to see is like a blank section in the page. A lot of the times you don't even notice it if you're not using it, right? So a lot of those things, the user experience is really changing. Also, of course, the speed of innovation is changing because of the user behavior, right? You want to cater to your users, and no longer doing 4 releases a year cuts it, right? You need to do smaller releases. You need to do it faster. And you don't need to be there's no need to be afraid to fail, right? So you can go into production. A lot of the times what you see with especially big monolith applications is the testing time itself is 2 months or 6 weeks. Just because even if you're adding a small feature, you're testing the whole application instead of just testing that particular service, right? So all of those things are changing, especially if you're moving to the cloud. You can't wait, cannot sit around doing 4 releases a year, because then you're not really exploiting your cloud infrastructure's capabilities. Also, of course, you need to do quick recovery and all of those things. All right, so I'm done with my why. Is there any question before I go into the what's in the house? No questions? Okay. How's the pace? Is that okay? Or do you want me to like go slower? Okay. Cool. Yeah. All right. So now let's look at certain design patterns and, let's talk about a little bit about microservices and how do you really build these applications for the cloud. And then we'll go into the hows. So in my experience working with, especially the financial institutions, what we have tried to do, and this is a journey. This is not something that you achieve in a month or 2 months. What we have tried to do is we have tried to plug in these like 4 pieces one by one. So especially if you talk about the culture, the DevOps culture, right? There's no longer, you cannot just push the application onto UAT and prod and push the blame saying that, hey, it works in my computer in dev. Why doesn't it work in UAT? Why doesn't it work in prod? Just because of all the reasons I talked before, right? You need to deliver software and you need to deliver as a team. And there's no longer this segregation between the development team and the operator team. So it's all the DevOps culture, and I'm sure you guys have all heard about it in details. Also, another thing is doing continuous delivery and integration. So there's a lot of tools available, and we'll talk a lot about them in the how section, that enables you to do these things. And these are really not even competitive advantage anymore. It's like everybody is doing CI/CD. Everybody is using Jenkins or some kind of tool to deploy software into production. It's no longer a manual release process on the weekend where you're like, okay, I'm going to release it Friday evening. It's going to take a day. And we're going to do smoke test. That doesn't happen anymore, right? And of course, microservices. And I'll talk a lot about microservices because in previous years, I've researched a lot. Everyone has their own definitions, but I've really seen what works and the way, you can approach it from the point of, let's say if you have a monolith, how you're going to move to the cloud. Or if you're building a greenfield application, how should you approach it? And containers. So containers, the reason it's here is what we have seen is, let's say when you have virtual machines and if you want to bring them up, the startup time and the, bringing down time is a lot. So when I say containers, I just don't mean Docker. It's all those, a lot of containers are out there. Also your virtualized infrastructure, right? So what essentially is a cloud native application, so by definition, it's an application that exploits all the capabilities of your cloud infrastructure. And in my experience, doing only one thing out of this doesn't really cut it. You'll always be missing something. So you will need to do all these 4 things, maybe not at once, or maybe you do bits and pieces. But at the end of the day, if you want to have a, cloud native application, if you want to leverage all the capabilities of the cloud, you would need to have all these 4 quadrants. And some of the properties of cloud native applications is, of course, these properties that I've talked before also. It needs to be event-driven. So it needs to be based on your user behavior. For example, Twitter or Netflix. When you click on something, depending on which device you're from, they know it, right? Sometimes they will use caching. They do a lot of different optimization based on which device you're from and what really have clicked around and event-driven. Also, you're reacting to load. So I hope my website, if I design something, it doesn't go down on Thanksgiving, right? And being resilient and being responsive. All of these are characteristics of a good cloud native application. Now, how do I build a cloud native application? What is the difference between traditional applications that I have been building and now I'm telling you, oh, cloud native application is the way to go? So the only difference is what I've seen from my experience is when you used to build applications, Java, Spring, any other language, Node.js, any other polyglot languages, a lot of the times we would not do all of these 12 things. We would just do maybe a couple of things, and then we will think about the design from the infrastructure point of view. So for example, if I have to store some configuration in a file, what I'll do is I'll make different configuration file XML files. And I'll say, okay, for development, I'm going to use this XML file. For UAT, I'm going to use this XML file. The problem with that is the moment you move into cloud-based infrastructure, and you can switch around the files and everything, but let's say if your application in UAT by mistakenly uses something from dev, your config file, then you would need to bring down your application again and restart it. And because you have cloud infrastructure, you can actually avoid restarting your infrastructure, avoid restarting your application if you make the configuration external. Why does your configuration need to be in your applications? Right? All these things. I'm not going to go into details about these things. 12-factor apps came out of Heroku. Have you guys heard about Heroku? Yeah. So it came out of Heroku, and they have been building cloud-native applications for a couple of years now. And they put this out. I have a link for this at the end of my presentation. It's a quick 20-minute read. So I would strongly encourage you guys, everyone to read this. And these things basically specify, this should be my properties of cloud-native applications. I talked already about config. I'm not going to talk about 12 of them. Just 3 most important things I feel is the config section of it. The second is the dev prod parity, as I was telling you before. This is really hard because I'm still a developer, but I have like a hybrid role now. When I was a developer, my development environment is always like a couple of releases ahead of production or UAT. So this one is really hard to maintain in terms of you can only maintain this if you're using fast releases, if you're doing releases every 2 weeks or every 1 week. So your production is in parity with what you're developing, and you're just not storing that in the branch, right? So this is, I feel, one of the most important things that we need to do. The third thing is treating logs as event streams. Now, I started off working with an investment banks. The way I used to write to logs is I used to store timestamp logs into shared folders. And I would not also have access to production logs just because it was all trading data, right? So if there was an error or something going on in production, we would back deploy it to UAT, try to simulate the same behavior so I can even look at the logs. Now think about doing this when you have deployed your application to AWS, or if you're trying to be, event-driven and be responsive and all those things. Like fixing an error would take you 2 days or 3 days. I don't know if that's acceptable anymore. It's not really, especially you will not have any competitive advantage if you do that. So in terms of logs, the way we can treat that is sending an event stream. So you can do like a system.out, println, and instead of you as a developer trying to write to like different files, you can just stream it out to something like Splunk. There are various log management systems out there, right? Ideally, I'll be talking about platforms a lot. Your platform, when you deploy an application to the platform, should be able to handle these logs, should be able to read these logs and retain it in some kind of a database that you can access later, right? All right, so 12-factor apps was from Heroku. We have a team called as the post-sales solution team, and their job is to migrate these applications, work with a lot of institutions, especially in Americas, and migrate these applications onto the cloud. So they looked at 12-factor apps and said, hey, I think it's missing 3 of these things. And so they came up with this book called Beyond 12-Factor Apps, and I find especially the first one very useful. I also have a link to it. It's a free download. You can read that as well. It's a very short read. The first thing is being API first, right? This is the 13-factor. So by API first, what I mean is, let's say your application A is catering to application B and C. Now, if you want to make a release for application A, your application B and C needs to be in sync. Otherwise, if you are a version ahead of, for example, application C, it might not be able to process the data that's coming from you, right? So now, what's the point of building microservices if you have to wait for other applications to get updated, right? There's no point. You're still stuck. You're still waiting to get released just because the other service has not been released. So the way we can overcome that is we can have different APIs, and we can say, okay, I'm going to release, but I'm going to have an API which is going to point to the earlier version of me. And hey, application C, if you're using the older version of me, please use that API version instead of using the latest version, right? As a result, I'm not stuck waiting for this application to be released, and I can move a couple of versions forward or whatever I want, right? Of course, there's a disadvantage to this. If you want to override a feature, you cannot do that, right? You have to wait for everyone else to be in sync. Other than that, this model generally works for most applications. Now, telemetry doesn't really mean phones or anything like that. What that means is having good monitoring capabilities and good metrics on your applications. So no longer do you have to wait for your operator to give you a call at midnight to tell you, hey, my application is down, what's going on? You can look at your application, have real-time monitoring alerts, so you know when the application is not working, right? You don't need to carry your pager, and I used to carry like BlackBerry because I was a developer all the time. You don't need that anymore. I don't even know if BlackBerry, maybe it's still in business. Don't use that anymore, right? And the third thing is, because of today's world, so many cyber attacks and all of these things, users are becoming really, really worried about their data. They're really becoming worried about authentication, authorization. And there was an incident even yesterday with our company data, right? There was an incident last year as well. And it really affects the way you're, kind of catering to your customers. And if once they lose trust in your application, I'm not sure even if it becomes like have really good features if they're going to come back, because they're always going to be like, my data is at risk, right? So you need to provide great authentication, authorization. There are a couple of ways to do it. There are third-party vendors like Okta, Ping Federate. That's their job. They have this application. You can redirect your application to them. Or you can also have your team doing this, depending on who you are. If you're a financial institution, if you're a startup, you probably don't even care about this, but you should. Depending on who you are, this is really important. All right, so before I go into this, is there any questions so far? No questions? Everything is super clear? All right. So let's talk a little bit about microservices, right? How many of you here are building microservices? 2, 1. Okay. All right. So 1. Okay. So I'm a little surprised, but I expected more hands to go up. But that's great. We can talk about, what they are, and then we can maybe, talk about building them. All right. So one of the things is, the moment we talk about microservices, everybody's like, oh, so the size of the service matters. So my application now needs to have only one feature or something I serve as, have 3 Java classes. That's not really, I think the name it's really badly named, right? Like other technologies, but a couple of things is, and I have taken this definition from Adrian Cockcroft, and what he says that a microservice is truly a loosely coupled service-oriented architecture. So it's SOA, right? But the only difference is it's loosely coupled and it has bounded context. So by loosely coupled, what I mean is, let's say I was talking about the microservice A, B, and C, right? Now, if I cannot release A without releasing C, it's not loosely coupled. So that's one thing. The second thing is it needs to have bounded context. So in order for me to develop microservices, if I need to know about all the different services that's there in the ecosystem, it's not a microservice. So I'll give you an example. In terms of, so I've worked recently with a bank, right? So they developed their retail application, but they had a monolith and they wanted to migrate that into microservices and move it to the cloud. So very typical use case, but it was a very challenging project just because A lot of them didn't understand what is a microservice, and every time it was like, hey, if I build this feature, for example, if I want to log into my application, why do I need to know about my balance, right? I don't need to know about my balance. All I need to know about is my username, password, and if I can really authenticate that user. That's all I need to know about the UI, right? The second thing is, when I go into my application, when I look at an order page, let's say, for example, Macy's, right? I'm looking at some dresses. Why do I need to know, let's say, about my billing information? I don't need to know that. All I need to know is my product catalog, right? That can be another microservice. So a lot of the times you will see, specifically when you have monoliths, all these capabilities, just because they have been written over 5 years, touched by various engineers, all of these capabilities sometimes get tangled together. And you will also see a lot of hard coding and all these things. So I'll talk about that later. But microservices truly is a loosely coupled service with bounded context. That's it. It can be big, and you can always do iterations. You can break it down. You don't have to come up with the right microservice on the first go, but these two things are very important. Of course, it's not a monolith anymore, right? And it's not an ESB as well. So a lot of the companies I work with, they move away from monoliths, but then they go into having something like an ESB where all their logic now goes into this middle bus. So your microservice is not really either of those, right? It's somewhere in the middle. Okay, so this is a diagram I took from Twitter. I think this is 2 years ago. So this is called the Death Star architecture. And what you see here, this is the real world view of microservices happening at Netflix, Twitter, Gill Group, right? And you see now it's become so complicated. Instead of having just one monolith, now you have all these various microservices. And this is a world view. So it's also different services from other regions as well. You see all of these microservices are interacting with each other. So now question for you guys, do you think the complexity has reduced just because I have now moved my monoliths to microservices? Or what has happened if you look at this? Increased, right? So it has increased and it has transferred. So moving to microservices is not a solution. Moving to microservices just means it enables you to do more things that makes your software really resilient, that can run on the cloud, right? And I'll talk about the challenges and all of that in the next slide. Before that, I want to stop here. Is there any questions? No? Okay. All right, so as I asked before, they might look simple, but they are not really simple. And all the complexities has now been transferred to not just one application, but to the whole ecosystem. So there are a lot of challenges, and I'll talk specifically about 4 of them. Of course, managing configuration, now understanding where did my service go if I have different microservices, right? So let's get into 4 of them. So managing configurations. Now, as I was talking before, every configuration is going to be different, right? My dev configuration is going to be different than my prod. Now, if I deploy my application to the cloud, how do I manage that? Should it be hard-coded? Should it be externalized? I touched already a little bit on that. We'll see how we can do that. We need to make external configurations, and we should be able to update these configurations dynamically. Why do I need to restart my prod application just because I need to change a value, which I can change on the fly, and hopefully the application, if it's dynamic, can pick that up. Service registry. Now, instead of having one monolith, I broke it down to, so many of microservices. Let's say now I want to my UI wants to find the product catalog. How will it find it? Right? That's one challenge of discovering these different services in the era of cloud, where even the URL cannot be trusted. And by the way, there's no ports in this world anymore. when you deploy applications in AWS, you cannot specify ports. Everything is going to externally run on 8080. So how do I find my applications in the cloud? The third thing is, and I think this is the example of Netflix that I gave you guys before, is when my recommendation engine goes down, my whole application shouldn't go down because it's just one feature. So how should I stop cascading failure, right? Instead of just one, if my one service goes down, how should I stop that failure cascading it back to my entire application? Another thing is latency analysis. Now it's going to be really difficult if I'm seeing latency in certain requests, specifically if it's coming from mobile or any of these different, versions of my applications. How do I debug that? So the good thing is I will talk about a lot of these things. The bad thing is I will talk a lot about these things. So I will touch upon all of these technologies. It is a lot if you have never seen it before. So I will be available for questions after the talk, and I strongly encourage you guys to ask questions. So the first thing is, let's talk about externalizing my configuration. With the help of software, it's called config server. So this is one way of solving the problem. There are other ways as well. So one of the ways that we have seen it work is, let's say now my configurations don't need to sit in my applications. I can send them to SVN, Git repositories, whatever your company uses. And then I can have this centralized server, which is an application, listening to the Git repository. And it knows which application in dev, UAT, or prod, what configuration is it. So you have kind of delegated this functionality out to an application. Instead of you as an application managing it, now an external application is managing this complexity for you. Now, how does this work? I'm not going to go into a lot of details. Just a couple of steps is, let's say in my dev environment, I push an updated configuration file into my repo. The config server can talk to the Git repo. And then when I deploy my application A into the cloud, it can ask config server, instead of going directly to the Git repo, it can ask this config server, hey, give me my configurations, right? Because it knows where config server resides, which is an application, and it can tell the different applications. Now, in terms of managing configurations dynamically, this is challenging because a lot of the times you don't want some configurations to get updated in production, especially if your user sessions are in flight, right? So you need power to control when can it be dynamic versus, which application can I really push this configuration to. So you might be able to push this to dev and UAT, but you might not, or maybe it depends on your product design, you might not be able to or should not push it to prod, especially if your user sessions are in flight. So with the help of a cloud bus, you see that in here, this is nothing but it's a queue. It's a RabbitMQ messaging service. It can be anything else like Kafka or any other technologies. And the way config server works is I send this message. I say, hey, I have deployed an updated configuration into my Git repo. I want my dev application to know it. I want a way to send a message to dev application so it can do a repo from config server, all without restarting itself. I don't want it to restart itself. So I can send a post message to my dev application, and then I can decide whether I want to send it to QA or prod. If I want to send it to QA and prod, instead of sending, so if I send it to only dev, it should be /dev application name. If I don't, I can do a post to an entire dev, QA, and prod. So if I do this specific thing, what it's going to do is your dev is going to send message to this queue, and then it's going to talk to QA and prod, and it's going to pull all the updated information. So let's track back a little bit. If I do this, all the applications, it's going to get updated. If I do just the endpoint of the application /dev, only my dev is going to get updated, right? And then I can decide, depending on how I send the signal, which applications I wanted to update, right? Also, here I've only shown one instance of the application. It might be various instances. So you can also control how many instances. You might want to do like an A/B testing. You can also control the number of instances you want to send this signal to. So sorry, I think you had a question?
Yeah, this is just really interesting to me. So in terms of using something like RabbitMQ or the config server and sending it to specific applications, I get all that. The one thing that I'm not quite sure is that when you're doing that, is it just queuing them for those to at the right point for you to be able to actually restart the application? Okay.
No. No. So let me repeat the question. I know they wanted me to. So the question is, if you're doing this, you're using CloudBus, how is it refreshing and, is it waiting for you to restart the application or how is it doing it? So the way it's doing it is, it depends on what signal you're sending here, right? The moment RabbitMQ gets this, it's sending the message to QA and prod. You control which configurations you want to get updated via an annotation or via it's also a config that you can control. So for example, in my prod, just for example, I have two configurations, configuration A and configuration B. I don't want configuration A to get updated in the middle of a production, So just for configuration B, I want it to get updated. And the way I'm going to control that is, hey, if I receive a message from RabbitMQ or CloudBus, I'm going to annotate it with refresh endpoint. So it's going to be at refresh scope. That's going to control the way my configuration is going to get updated. The whole point of doing this is I don't want to restart my applications. So that's the whole purpose of doing it. And I will talk a lot about Spring Boot and the capabilities of Java. How many of you here are using Java, Spring? Okay, couple. Okay, that's good. There's also other things that's like if you're not using Java for Node.js and other things, we can talk about that later as well. But Spring Boot, which is built on Spring MVC, Spring IO, I'll talk a lot about that in the how section of things. It really enables you to do this very easily. All right, so before I move into the second design pattern, is there any other questions? Yeah?
So for Cloud Foundry, what is actually doing the config server job? Is that the cloud controller or is it Diego?
No, so the question is for Cloud Foundry, what is doing the config server? So for Cloud Foundry, it's not built in. You would need to use Spring Cloud Services. Yeah? So config server is part of that. The second design, by the way, is there any other questions? No? Okay. The second thing I'm going to talk about is doing service discovery and registry, and how do you do that, and what design patterns are there. So one of the ways you can solve it, and I know there are other ones as well coming in from console and all that, but today specifically I'll be talking about Netflix's Eureka. Netflix has open sourced their stack. As a result, you can see these technologies coming out of it. So Eureka, the way it does it is it locates service not by the URL, but by their service IDs. So when you deploy your applications, Eureka knows you have deployed application A, B, and C just because you send a ping to Eureka. And you will send a ping every 5 seconds. So Eureka will know where you reside. As a result, let's say my microservice A now, which is a fortune service. So my example here is a fortune teller app, and it's just 2 microservices. Very simple. It has a fortune service and a UI service. So now my UI asks, hey, where is my fortune service? Instead of going to it directly, I can ask Eureka, and Eureka will know about where is my other service. Just because when I came up, I told Eureka, this is where I am. and I need to send pings to Eureka every 5 seconds. If I don't, Eureka will mark me dead. And let's say when the fortune service comes up next time, it will send back an error message that I need to handle on my side, just because it cannot find the UI service. Okay, how does it really work? So as I said before, when you come up, you either restart yourself or you get deployed. The applications connect to Eureka, which is similar. It knows where Eureka is. By the way, you can also run this in your computer, laptop. They're like individual services, or you can also deploy it on cloud, like AWS or anything. So I will know where my application is. I connect to it. I send heartbeats to it every 5 seconds. And next time, if I'm looking for a service, I ask Eureka, and it's going to give me that service. Now, one of the good things is, let's say, this is only one instance of the application. Let's say I have 2 more instances of this application. One of the instances have gone down. Eureka can also load balance. Eureka knows the first instance of the application has gone down. So next time I ask, where is my fortune service, is going to send me to the second instance of the application, just because it knows the first instance has died. The second thing is, when I connect, I don't want to go and ask Eureka every time I connect, right? What I do is, when I connect, I can cache the location of this service. But there's a caveat. If I cache it in cloud, and if this instance goes down, next time I'm sending a request, I'm going to get an error back, right? So I need to handle that in my side. So the moment I get the error, I can go back to Eureka and ask, hey, this service has gone down. Do you have another instance of it? If you don't have another instance of it, I'm going to handle the error on my side, right? So these are just some design patterns that can help in registration and discovery. Is there any questions on this so far? Yeah?
If you're using the load balancing feature with something like Eureka, would that work for both active-active and active-passive?
Yeah, it's going to work. But then the only thing you have to keep in mind is Eureka is a single point of failure, right? So what you would need to keep in mind is you would probably need to have multiple Eureka services, or you would need to handle that on your client side as well. Sorry, the question was, if I use Eureka, will it work for active-active and active-passive as well? And you heard my answer before. Okay. The third thing I'm going to talk about is handling failures. How do you handle failure with microservices? So one of the things is, again, it's an application. It's called Circuit Breaker. So let's say when my microservice A, this one, breaks, I can have an application then that knows that, okay, my application A has gone down. Since it knows my application A has gone down, application B, C, and D, it should not be affected. And the way you can, achieve that in your code is you can have a fallback method. It's basically like a try-catch, little complicated try-catch. So you know that, okay, my application A has gone down. How do I handle it? I have a fallback method. What is my fallback method? It can be anything. It is like, instead of giving 404 error, it can be displaying a blank page. It can be, trying another service through Eureka. And by the way, all of these design patterns are meant to work together. So you can use other design patterns with Circuit Breaker. And another thing is, let's say you have a request coming in. It comes into application A. Since my circuit is open, this application Circuit Breaker knows I don't want to send the request to this application because it's gone down. And it will ping it I think the default is 5 seconds as well for this. Pings this every 5 seconds. And the moment it comes back up, that's when it starts sending all the requests to it again. All right. So the way this works is kind of like an electrical circuit in your house. Instead of, let's say when your circuit trips, your entire power system doesn't go down. What happens is it trips the first time, right? So it's similar. When you have everything working fine, the circuit is closed, and that's why it's named circuit breaker, maybe a good name in this case. Closed, everything is working fine. The moment there's a failure, it opens. When it opens, it checks it. It checks the service every 5 seconds. The moment it sees that it has gone back, it's restarted or whatever, it has handled the failure, it goes back to being closed, right? This is the internals of it. So is there any questions on this so far? No? Does this make sense? Yeah? Okay. The final thing I'm going to talk about in this section is tracing and latency analysis. So there's a lot of technology out there. This technology specifically, Zipkin, came out of Twitter. So during a hack week in Twitter, they built Zipkin, and it's based on the Dapper paper, which is Google's tracing system in production. And I have links to all of this in my last slide. So what this says is, I want to know, so this example, I have 3 microservices. I want to know the entire latency of the request. I'm not going to go into internals on how it does it, but the way you can see it on this dashboard tells me the total latency of the call, and it breaks down to every microservice, how much was the time in every microservice? How much time did I spend, right? And so this entirely is an hour talk, which I did last year. So one of the things is, just an overview, is it does something called, you see there, traces and spans. So traces is how many microservices did I touch in one request, and span is every time I touch a microservice, a new span is generated. So a trace is something like, you can think of it like a tree of the entire request, how many microservices that touched, and a span is just one particular microservice. And as a result of this, with the help of traces and spans, I can now calculate my latency, entire latency. Another good thing of this is this graph. The reason I like, these are my other applications, don't mind them. The reason I like this graph is, sure, I have 3 microservices, but now think about, remember the graph I showed you with Netflix. Think about if I have that, and if I just look at this graph, I know which service called which one. Another good thing is, which you don't see here, is depending on if service 3 calls service 1 versus how many times it calls service 2, the lines become darker. So your visualization will be like, okay, I know service 3 calls service 1 more number of times than it calls service 2. And when you click on this, you can see, so I can show you the demo, I have that. You can see how many times it called it and what are the times you called it. So a lot of the times what we have seen is, this is really useful. And you can take the trace ID and span ID, go back to your logs, because it writes it in your log messages, and see exactly what's going on in your logs. And do you guys know ELK, Elasticsearch? Yeah? If you use that, they also provide a dashboard for this, for log correlation with Zipkin. All right, so I've talked about what a lot. So is there any questions so far? Yeah.
So where does Amazon Lambda, where does that come into picture? Because that's serverless application. Here,
yes.
Where we talked about is a server that maintains everything, right?
Right.
Where does Lambda come?
Right. So Lambda is more like a function as a service. So, it's more like in tools when I talk about how, although I don't cover Lambda at all. So what Lambda does is it helps you to deploy certain functions into AWS, and it's built into it, right? And it can run for, I believe the configuration is 5 minutes or so. So if it runs for 5 minutes, let's say, think about it like a batch job. You want to run a batch job for 5 minutes. You can deploy that Lambda function onto AWS. And the moment that job finishes, you're done. So your EC2 resources, it frees up and everything, right? So it's just another layer, which is, they call it function as a service nowadays. So I don't know if you guys heard about infrastructure as a service, platform as a service. Now it's function as a service and serverless architecture. right? So that's where the really like advanced technologists are headed. Yeah, so it's all the culmination of all these technologies is really what use case are you using for, right? If you want to use it for a bad job, sure. But if you have a long running process, like a trading application, you cannot use Lambda for that, right? Maybe in the future you can, but till what I've seen till date is not yet. All right, is there any questions before I go into the last section? Wow, okay. I have 9 minutes left. 1 hour really flew by. All right. Is there any questions? No? All right. Let's cover the how. So I've talked a lot about it already, and hopefully how should be very intuitive. Okay, so I know a lot of you're using Spring already. Have you guys heard about Spring Boot? No, some of you. Okay, have you guys started using it? No? All right. So if you're using Spring, I would say really like look into Spring Boot just because it's just the same thing, but all it's doing is it's really opinionated. So it reduces a lot of those XML files. So I really didn't like Spring when I started using it after school because there were so many XML files, so many configurations. I didn't like it. But now with Spring Boot, it takes over all of those XML files. Yeah.
So Spring has a lot of annotation.
Yes, Spring Boot.
Yeah. So Spring Boot is just another flavor, but everything is in the code itself. It makes it kind of funky. XML thing is kind of, if you want to have to change it, you don't have to change the code. It's just a configuration change. So the configuration can be tailored to a specific environment. But for the Spring Boot, you have to leave it have to change the code.
Yeah.
What is the pros and cons of Spring Boot?
Sure. Yeah. Sure. Yeah, I'm going to cover that. So I was going to cover that. So the reason it's opinionated, it assumes a lot of things. And as you're saying is annotations, it assumes that you use certain configurations that you would use in an XML. So I don't know if you have used Spring Boot libraries. So when you download the libraries, if you click into it, you will see the XML configurations. They have not gone away, but they have just assumed that you're going to use that annotation. The second thing is, what I've seen working is hybrid. So instead of using entirely Spring Boot, some applications are not suitable for it. Just because you want to have a lot of custom, integrations, your custom, implementations of certain things, then Spring Boot is not a great thing. What Spring Boot is really powerful in is if you're building any application like web applications or any of these applications, and if you're using those design patterns, as I talked before, and if you want to take use of the annotations, use of the opinions that this language framework is providing, that's where it's really useful in. And it has exceeded, I think it's over 10 million downloads now. I'm working with a specific retail company also to migrate their applications into Spring. So when you do that, you would need to do analysis on your application. You would need to see if they're really suited for Spring Boot for sure, right? So if you have taken it out, I can take this conversation offline with you in depth. I would like to understand why you made that decision. Yeah.
I think that there's something you might want to try it, but when I try it, I don't like it for many reasons. And one of the reasons I say there's no XML, yeah, sure, but Spring doesn't need XML either. You don't need to go to Spring Boot because, you can get rid of the XML. XML is because of you. What you can tag is services and controller, whatever, components, and they all understood. And all you need is like you get a package, you scan the package, and then it's going to start everything you want.
Right.
And another thing that we've done in our project is that because we support both public cloud and private cloud, so some of the services not suitable for the private cloud, and we have our own annotation.
Yeah, that's why.
Services. I mean, it's really cool, and we always promote it. How are we going to do that?
Yeah, you shouldn't.
Okay.
You have a lot of custom annotations. You do a lot of things custom already. So, and I can take this conversation offline with you for sure. Yeah, so then that's when you're going to face challenges. The second thing is Spring Cloud. I talked a lot about config server, Eureka, circuit breaker, all of these technologies. Most of them are coming out of Netflix. There's also a lot of technologies coming out of Console, Twitter. So what Spring Cloud really gives you, it's a project, again, a project umbrella of Spring. It gives you various options of choosing. Like, let's say if you don't want to use Eureka for service discovery, you can use Console, or you can use various flavors of Spring Cloud. By the way, all of this is open source. So again, you can try it if you don't like it. Depends on your implementation. You can take bits and pieces from it. I've also seen a lot of custom implementations on top of Spring Cloud. So it really depends on what you're using. So all of these design patterns, right, in terms of configuration management, as you were asking before, config server, it's coming out of Spring Cloud, the project. And all I needed to do was I needed to attach that application to my microservices. And I needed to tell it where my Git repo is, which is here. And my configuration in my code, this is how I need to access the values. So instead of telling it, hey, I want to access this configuration from the config file, I go to config server and access this configuration from GitHub. So I know where my config files are now because of config server, and I can just access them through. And again, this is just like an overview of what it is, right? The second thing is service registration and discovery. Sorry, I'm rushing a little bit, just 3 minutes left. Service registration and discovery using Eureka, which is Netflix's project again, is something like this. So when I deploy my applications, it registers with this application called Eureka. I can then see my applications. You can see they're online. You see up. You see there are only one instances of these applications. And then in my code, instead of accessing the application using URL, because if my application is in cloud, I might not know the URL, or the instances might go down. I just access it like this. And then Eureka is going to handle routing and load balancing, as I talked before. Circuit breaker, again, the circuit looks something like this. So it's a dashboard. And here you can see in my code, what I have said is, if my fortune service goes down, my fallback method is this method, default fortune. So although my fortune service goes down, I'm going to display just this fortune to the users. And how do you see that your circuit is open and it's failing is this. You see 100% random fortune. So instead of making calls to this method, my requests are getting directed to default fortune, which is the random fortune out there. And this is again Spring Boot annotations. So at enable discovery client, circuit breaker. Discovery client is for Eureka, circuit breaker is for just for that. I talk a lot about that as well. In terms of platforms, there's a lot of things out there. Structured platform, unstructured, Docker, Kubernetes, OpenShift. There's a lot of things out there, right? The only difference is you have to understand your applications and you have to understand what do you need from the platform. Do you need the platform to do monitoring? Do you need a platform that you can just deploy the application and it's going to take care of all the auto scaling for you? If your application goes down, do you want your platform to do health management for you, to send you alerts? If you need all of those, then you need a structured platform. And Cloud Foundry is a structured platform. I work for Cloud Foundry, but I've also researched a lot about Kubernetes. I've used OpenShift. So I know if you want to talk about this, happy to talk about it after the talk. And one of the last things, but it's very important, is having, cross-functional team, mainly 2 pizza teams. So it came out of Netflix, is if you have a team which requires you any more than 2 pizzas, then your team is too big. So it's like your team needs to be small and it needs to be cross-functional. No longer can you have a team that only your UI developers is one team, and then your backend service is another team. Your tester is another team. Because then what's going to happen is it's never going to be my fault. It's never going to be the fault of my team. It's always going to be fault of that team who's doing testing or who's doing the backend service, right? So the whole magic of doing this right is having the culture, having the right team, and having the right mind, like the frame of mind. That's the most important thing. Technologies, you can plug, play. There's a lot of things out there. You can do it. And of course, having test-driven development, testing your development already, and doing short iterations of your applications. And this is my last slide, is everything is a journey. Start small. It's like, same thing. When you start speaking, start small, build it, migration, do it. Don't boil the ocean. Pick the application. You can pick any application. Ideally, you want to pick something that has a high business impact. This is kind of counterintuitive, but the reason it works is then you have a lot of eyes looking into it, and it's easier to get your, business, you can convince your manager, convince the managers on top of them to use this, and it really works. So you can, build the platform or use other platforms. You can use the design patterns that I talked about. There's a lot more stuff out there. And also continuous integration and deployments. That's another big piece of the whole thing. So with that, I would end my talk here. But since I know I'm running out of time, but I don't know, do I have 5 minutes for questions?
Well, first, let's give you a big thank you.
Okay. Thank you.
And let's see if there are any further questions in the room.
No questions, but a quick correction. The two pizza team is a Jeff Bezos concept.
Okay.
It's
Amazon. Okay.
Concept, and then people from Amazon moved to Netflix, started working there, and they follow the same concept.
Okay. Okay. Good to know. Thank you. All right. Any questions? No? All right. I'll be available after the talk as well outside. So if you guys have any questions, feel free. And the slides is going to be available. And all the resources are right here. So you can either take a picture or you can access the slides later on. Right. Thank you, everyone.